Hi, welcome one and all. And on behalf of Laser World of Phonetics India, I, Dr. Subrato Dey, I welcome our today's senior scientist. And today's is Phonetics Exchange and broadcast partner Laserman. And with this, let us introduce our today's guest. Today's guest is Dr. S.M. Shariff, Senior Scientist FARCI. Dr. S.M. Shariff is a senior level scientist at ARCI based at Center of Laser Processing of Materials, Hyderabad, and his work in applications of across sectors such as automotive energy and allied industries with surface modification brings enhanced performance and durability. He has got around 25 years of experience, and he has contributions even in papers, research papers in cladding of compositions, TIB, TIC, ALO, and even lot of experience sir has got. So welcome you, sir, for today's show. Great. So my question is, like, could you walk us through the evolution of laser surface technologies at ARCI from early developments like laser hardening to more advanced processes accordingly? Will you please, sir?
Yeah, thank you for this explanation, asking these things. See, I had been in the RCI since it's basically 2-3 years of inception of this laser, India's first laser high power laser materials processing center. During that period, initially we had two lasers which had been brought from Israel. And they were CO2 based lasers. At that time, CO2 was the main laser,
Exactly.
which has been extensively started using, people started using.
Sir.
So one of the lasers was we dedicated for cutting, that is a low power CO2 laser. Another was high power CO2 laser, which is a 9 kilowatt CO2 laser from Israel. So with one laser we started doing basically this machining processes like cutting and drilling of sheets and plates and all those things. That includes even normal materials as well as super alloy materials also, which are used for defense applications also. Apart from that, with respect to surface hardening, surface modification technique, we have a lot of surface modification techniques, basically like hardening, melting, alloying, cladding, glazing, all these different varieties depending on the domain which you have. So depending on the application, you use a specific domain. So initially we had this 9 kilowatt CO2 laser. In fact, it was the first of its kind in the country, and we used to struggle a lot basically to maintain the laser.
Exactly.
Because at that time,
right.
It is a slow flow axial laser, where that in that resonator we have to pump all the gases and also high power, and then we have to maintain the cooling system. All this is a complicated thing which was required to, especially when high power comes into picture, maintenance will become a little bit difficult at that time, because individually it has to be pumped, these lasers. Then over a period of time we were able to manage with the help of the experts, because this was the brainchild of Dr. G. Sundarajan and his and Professor P. Ramarao. They have under that their tutelage we got this one, and I started using that one for laser hardening specifically. Initially, I tried to do on different steels, and in that CO2, when you use CO2 laser, it requires some special absorbent coatings, because that absorptivity will be very less with respect to metals. So for that purpose, we need to have additional coating. That will when you apply actual laser, then the turbulence it creates in the surface, that results in partial melting and disturbance in the surface. So definitely, such a laser surface hardened with CO2 laser requires post grinding. So that was the stage when surface modification, especially hardening, started. And also we also had additional powder feeder to simultaneously melt the feeded material along with the substrate, so that you can deposit a layer which will be different from that of substrate. That's how it is laser cladding, and it has been started. Then over a period of time, lot of evolution itself has happened in this field all over the world actually. Then then we increased it to applying NdArc laser, which will give a better better absorptivity because of its lesser wavelength than that of CO2.
Mhm.
Then with this NDR laser, we started doing some because at that time high power was not there. Then we had to use within that available power some thin section surface modifications we started, and then we progressed from that to a very versatile system. Now also you have, and it is globally used, where it is called high power diode laser system. That laser has got a very good absorptivity with metals. In fact, it has got better absorptivity with certain materials like aluminum also. So you can use this laser for surface modification
Okay.
without using the absorbent coatings which I have used earlier in case of CO2 laser. So that you can have a very clean process also,
Okay.
because you are not doing additional absorbent coatings like graphite coating and all. So this has helped to increase this applicability in a wide spectrum because of this. Because of this, now it is widely established. In fact, we had developed the first project we had to put it into prototype level and production is related to, we had a joint project with DRDO,
Okay.
that is DMRL,
Uh-huh.
and BHL
Mhm.
and ourselves.
That's
ourselves.
great. That's great.
So that we are the first people to introduce that laser surface hardening treatment for steam turbine.
Yeah, I learned. Once I learned this. Yeah.
So that was the thing, and then we have even went up to production and delivered up to different multi-watt level, different type of steam turbine blades,
Yeah, exactly.
and then it ended up in establishing the system itself in BHA.
Okay.
So
okay,
that much
okay,
level
okay.
it has gone.
That's wonderful. Wonderful.
Uh,
Well, my next question, Dr. Sharif, is like ARCI is basically known for like bridging a gap between research and industrial deployment, right? So, could you share examples of how you work in laser surface,
yes.
right? And that too in the modification part. So, can you please explain?
Yeah.
please?
See, in fact, ARCI is an autonomous center under Department of Science and Technology.
Exactly.
Its main purpose is to bridge the gap, as you rightly said, between the industry and research.
Okay.
So we concentrate basically on applied research.
Mhm.
So which will lead to industry specific, industry centric.
Okay.
Because any problem, whatever industry faces, they can come to us. Especially in these domains, we have 5 different domains.
You mean to say like a complete solution?
Yeah, complete
Like
solution.
complete solution you
Yeah.
can provide.
Right from
That's
the
great.
basic research, because it is backed up with a high-end characterization facilities also.
True.
That helps to go into deeper, because it is backed up with strong scientists also. So we can understand the basic thing and then try to apply. When you apply in any industry, complexity comes into picture.
That's true.
The reason why it comes is, when we do in research, we do in a specific set of parameters. Parameter specific.
Yeah.
When it comes to actual part, it will be totally a different scenario.
Yeah, that's
So there you require this, what is its repeatability of the system which you are applying.
true.
Because again, it needs to be checked before doing it on actual part. For
Actually.
example, if you take, as I told you, whether, for example, laser hardening of camshaft, crankshaft, piston ring, all these things I have done. So there also, you need to have a surface preparation appropriately. You may have a particular preparation in research, but different scenario when it comes to the part. Then you should know how you have to focus the laser, so that at that juncture, proper energy density impinges on that.
Yeah.
So that requires some engineering skill,
yeah.
where you have to see the design
Because
of the
without
part.
skill, like one cannot go with this
Yes.
this type
Yes,
of
yes.
learnings and all.
So,
Experience matters.
yeah.
True.
Then comes the next stage after doing is prototype level development, and then real
prototype.
plant testing,
Mhm.
which we had basically done in couple of applications in power and energy, and even in nuclear reactor also things we had done. Few
Okay.
of them.
Okay.
So we had a lot of applied research, basically not only in the surface modification, we also have in additive manufacturing, laser based additive manufacturing,
But what I feel
laser
like
joining, laser
exactly, sir. What I feel like there are some challenges also. Like my next question is, what are the biggest challenges in scaling laser surface technologies, right? From research prototypes to industrial scale application, and like how can you overcome it?
Yeah, see, another important aspect, because it is laser processing is a multidisciplinary thing when it comes to industrial
Exactly,
implementation.
sir. Exactly.
So what you require is some software people is also required, CAD
Uh-huh,
model
uh-huh,
using software people.
True, true.
Because you need to know the design of that part. That whole thing you will load. You will have some CAD CAM software also attached. Apart from that, you will also have some optical tools, how to measure the laser intensity, beam profilometer, all those things. So it requires a combination of materials combination people, as well as mechanical engineering people, as well as material science people.
So you mean to say like overall like multidisciplinary approach must be
Yes.
there. Then only this is
Yes,
possible.
yes. That's where country needs some specific workforce.
Great, great. Wonderful, wonderful, sir. So as per you, sir, what are basically like, how important are the collaborations with industry, right? And that too, even in academia and in startups, with startups also in like advancing laser materials and like in processing research, especially in India.
Yeah, because people many a times in industry, especially initially, it was the fear of laser because of that wavelength.
Maybe wavelength and maybe knowledge also, sir. Because
Yeah.
I hope like regarding the knowledge also, right, sir?
Yeah, because of that fear, there were not
Fear factor,
many
fear factor, right,
workforce
right,
people.
right.
Now
True.
it has become very common because why it has become widespread means even eye safety has also improved a lot
Eye
now.
safety, true, true, true.
Not only with respect to wearing the spectacles, we can also have a safety cabin also. Under that also you can work. You can also use the glow box so that when you are using the powders for deposition also.
Exactly.
See, the thing is when it what basically requires is unless we build the laser,
Yeah.
that laser processing field will not improve in India. Of course, we have some new, not only new, old comers like Sahajanand Laser Technology also. They build the laser, and also some other companies are also available privately where they can those lasers can be indigenously built and can be used. That's why it is picking up now, basically. This laser processing.
Now it is actually picking up, and like people are taking more interest out of it.
Yeah, and with respect to laser machining, specifically for cutting, drilling, it is widespread now. Lot of later laser systems are available. Lot of changes have happened in the processing, cutting, drilling heads.
Dr. Sharif, I have like noticed a few things that especially like your group has worked extensively with microstructure and even like microstructure control and even like in composite coatings and all with like, could you highlight some of the most exciting findings or breakthrough from this research or like accordingly?
See, laser is basically a precisely controlled energy tube.
Energy tube. That's true.
So
that's true.
the more you can precisely control both temporally and spatially. Because of this, you can use this in specifically where whichever localized region is required.
That's true. That's true. That's true.
So two, three couple of things I will explain. Excited things which we have developed at our center. One of the thing is microstructurally tailored blanks.
Okay.
I call it like that because you are maybe aware of in automotive structural parts. You require a combination of high strength blank, but at the same time when you are forming, you need to have some softened layer.
That's true. Yeah. Of course.
So that there you require a composite steel structure. Wherever you are doing forming, you can soften the material. The rest of the thing can be like if you use a dual phase steel, then you can use this, and then at that particular part you can form. Like it will become a complex structure, composite complex structure, which you can effectively use for lightweighting purpose in automotive.
Exactly.
That is one such example.
Exactly.
Another thing is we have developed a composite multi-matrix composite coating, where it has been implemented in thermal power plant. So in a composite coating, metal matrix composite coating, for example, if you take tungsten carbide, hard particles you will embed in soft matrix. We have tried chromium carbide and tungsten carbide into the nickel chromium soft matrix. That has enormously helped basically to improve high temperature erosion corrosion, which we have developed, had been put up directly to the plant and tested. The technology is ready for transfer. It has been tested in two thermal power plants, basically NTPC Korba and NTPC Farakka.
Wonderful.
It has given almost 3 to 4 times that of conventionally used coating technology as of.
Great. Wonderful.
And that will also help in basically, as I told you, as a part of indigenization and Atmanirbhar Bharat.
Right. So what message you would like to give to young scientists and even engineers who are interested in working into like materials processing and even surface engineering? Any short of message, sir?
See, I am very much fascinated with laser
Yeah.
because I have been working for so long, nearly 26 years.
And 25 years is not like,
It's not as nothing, but
great, great.
see, I used to think that laser are only for manufacturing. No, it is
Sir.
also in different things, as many of us know.
Sir.
Even children also know what is the laser because we know the pointing laser, how
Exactly,
to play with the
exactly.
laser
Yeah.
in holography and all those
Exactly.
things. So it is really a very fascinating tool which can be gainfully utilized
Uh-huh.
for any application basically because it is the energy in hand. Most of the people say it is energy in hand means you are controllable both spatially and temporally, so that you can use in plethora of applications.
Great,
So
great.
you name it, it is there. Laser is there, as you may be aware of it. So definitely, I will prefer that all engineers basically to have interest on this laser as
Exactly.
a tool for various, not only manufacturing, even for cosmetic purpose also it is there, even for medical purposes also there. I would.
I hope like
these
all
engineers-
young scientists, must
Yeah.
be like they must be inspired and motivated with like great inspirational talks of Dr. Sharif. And finally, sir, just I want to introduce like Leisure, this magazine. This magazine, basically, we are working for the same Leisure World of Photonics magazine here. Sir, we are basically the magazine which we are covering like advertisement and even like the consultancies, and even there are a lot of things like regarding the repair of material, repair of machines and everything, even research and publications also. We are covering articles from the academicians, even industry people and all. Any message for us for Leisure India magazine?
Yeah. For the magazine, I would like to say that in India, it has grown manifold, especially laser-based manufacturing.
Yeah.
It is you should cover article in each wherever system is installed in the country, unique processes.
Okay.
Each
Yes.
article should be covered
With the unique processes.
unique process.
Yeah,
Like
yeah.
for example, we have a automatic seam tracking based laser brazing system.
Okay.
So you can go to the institutions like ARCI and CAT Indoor and also CMTI, these such organizations, and also wherever these new systems are installed, laser based,
Exactly.
you should cover the articles. It should come on a regular basis. I would prefer in a monthly
Because
basis.
so that lot of knowledge like
Knowledge.
young like citizens
Yeah,
can get.
and it is it possible in your magazine to publish some research articles also?
Definitely,
Then
definitely.
why
Research
the-
articles and all,
Yeah.
even like even like for the businesses also, they also can have their promo. They also have their knowledge that yes, what are the specialities are available in
So
the
you
world
can
of
put that
leisures.
indigenously developed
Indigenous.
systems also.
Exactly,
That also
exactly.
you should cover.
Great.
And because new concepts basically
True, true, true.
that you can have a separate section
Separate
so that you can improve.
Sure.
It should come to that our research fraternity also. That is what I mean to say.
Yeah, yeah.
It will attract.
Great. So, sincere thanks to Dr. Sharif for his wonderful thoughts and wonderful ideas which we shared in this. And thank you so much.
Thank you.